All right. I know this is a review of area of polygons, but it's necessary in order for everybody to have the notes. So if you already have these notes, then you don't have to worry about taking these notes. You can move on to the next assignment. But if you have a triangle, which is also another word we can use as polygon, and think of it as being inscribed in a circle. This is the side of the triangle. This dotted line to that part of that side of the triangle is called the apothem. That's something new, right? And this side here from the center can also be, if I'm talking about the circle and looking at the center of this triangle to the edge of the circle, that can be considered the radius. And this is considered the center of the polygon, which is inside the circle, which is the center of the circle. The angle here can be called the central angle. So we're going to review those things. Now, we know that all the angles in the triangle add up to 180. But just to have it in our hat, we know that n minus 2, n is the number of sides, times 180. That is our formula for finding these angle measures on a triangle. So, where n equals the number of sides. Now, some of you may have had this or remember this, some of you don't, but I want you to have that as area doing. Now, the central angle, if I have this circle, I know that I can make 1, 2, 3 of these shapes inside the circle. This is 360 degrees. So I know that central angle is 120. This is 120, then that's going to be, if I divide it in half, that'll be 60. So that's just a little mini lesson. So now if I want to find the area of this triangle, no, you no longer see a circle now. But I want to know what the apothem, what's the length of the base, the area of this triangle, and the area of the polygon. So when I say area of this one triangle, you don't know how to find the area of a triangle. Okay, so how are we going to approach this? Well, I can make, let's see how many triangles I can make here. 1, 2, 3. 1, 2, 3 triangles. So this would be 360. The central angle is 360 divided by 3. So my central angle measures 120 degrees. You say, what? Well, don't worry about that. Just roll with the flow. You're writing notes. Some of you have seen these notes before. Some of you never seen them before. But just note that I divided this triangle into 3 equal triangles, and think of it being in a circle divided by 3. I know a circle has 360 degrees in it, so that central angle right here is 120. Now, that means that this angle measure is 60. 60 and 60 is 120. And then if this 60 and this is 90, then this would be 30. Right, let me zoom in on my picture so you can see my labels. All right. So this is my apothem. I'm going to label it with a little a. My base is this. So this is a 30, 60, 90 triangle. Now, early in the year, we did right triangles. There's special triangles where this X is our short leg. This is our long leg. That means the side opposite is the long leg. and the hypotenuse is 4. So here we see that the hypotenuse is 4. So here's my equation I'm going to use to find x. So I have 2x is equal to 4. Divide by 2. So I see x is equal to 2. That's how I got it from it. So since I know x is 2, then the side opposite of the 30 is equal to 2. The side opposite of 6 is 2 square root of 3. So this side is 2 square root of 3. If this from here to here is 2 square root of 3, then this is also 2 square root of 3. All right? So what is the length of apothem? Apothem is 2. You see it is here. Apothem is 2. The base is 2 square root of 3 plus 2 square root of 3, which is 4 square root of 3. So what is the area of one triangle? One triangle will be 1/2 the base times the height. So we remember that from our last one. That's why we started with the simple first. So that would be 0.5 times 4 square root of 3 times 2. So we're going to put that in our calculator. Let's put it in parentheses. 0.5 times 4 square root of 3 times 2. We get 6.928. So the area of one triangle is 6.928. I don't know why I was writing that. So that's approximately 6.9, right? So what is the area of this polygon? How many of these I have in here? This 6.9, this 6.9, that's 3 of them. 3 times 6.9, that gives me what? That's 20.7. So the area of this polygon. So it's kind of like finding area of a composite figure. A figure that has shapes inside of it. This has 3 triangles inside of it. So the area of this polygon is 20.7 units squared. I don't see any units on here, so I'm put square. Let's move on to the next shape. This is a square, and how many angles inside a square? How many sides on this square is 4? So this was inside a circle, then I would know what the center angle is, but there's all kind of ways to approach this. So let's identify what this angle is. I'm going to draw our line here. So we have our apothem. We know the length of this side, but we don't know the length of this side. So we need the measure of an angle. Right? So we have how many triangles? 1, 2, 3, 4. 360 divided by 4 is 90. So if this is 90 degrees here, if I cut it in half, this is 45. And this is 45. So my central angle is 90 for this shape. What is the central angle, Ms. Chambers? What are you talking about? I'm confused. This is the central angle. It's 90. When I divided it in half, it became 45. How did I get the central angle? I took 360 divided by 4. That's how I got it. How did I get the central angle on this one? On the triangle, I took 360 divided by 3. Got it. So when I divide this in half, that's 45. So that means it's a 45, 45, 90 triangle right here. these are the attributes of a special right triangle. So I have the hypotenuse, which is 4 square root of 2. But I don't know what x is, but this is my equation to find it. So I know that x square root of 2 is equal to 4 square root of 2. So how I'm going to find x? I divide both sides by the square root of 2. So x is equal to 4. Since x is 4, that means that this side is 4, and this side is 4, and this whole side is 8. So the apothem value, which is this length going down to this side, is 4 units. The center angle is 90 degrees. The base is 8 units. The area of one triangle is 1/2 the base times the height. So it's going to be 1/2 the base, which is 8 times 4. So that comes out to be 16. So the area of this polygon is going to be 1, 2, 3, 4 triangles. I don't know if you see them. But there are 4 triangles here. So it's going to be 4 times 16, which is 64. The area of this triangle, this polygon, my bad. The area of this polygon is 64 units squared. All right. You say, well, we could have done this a totally different way. These are triangles and squares. You're right. So let's look at a pentagon. I wonder if I give you a pentagon and I ask you to give me the area. All right, so you need to draw a pentagon on your notes. If you're not able to download this page, you need to draw a pentagon on your notes. So what's going to be the center angle? What is center angle? I tell you again, the center angle is this angle here. How many sides this pentagon has? 1, 2, 3, 4, 5. So that's going to be 360 divided by 5, which is what? 72. Center angle is 72 degrees. Okay. So we're going to divide that 72 by 2. We get 36. So when we divide in half, this is a 36-degree angle. And this whole side is 6, so this is going to be 3. But this is not a special right triangle or anything. So we're going to use what is called SOHCAHTOA. Sine is opposite of hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Sine, cosine, tangent. For those who've never heard of these words, I'm writing them for you. We say SOHCAHTOA because it helps us to remember the formula. So what do we have? I have a side. Here's the hypotenuse. Here's the apothem, which is another side. So what side do I have in reference to this angle? I have the opposite side. So I have opposite here and opposite here. And I'm looking for the adjacent side. So I'm going to use tangent. So I know that the tangent of 36 is equal to 3 divided by the apothem, which is 8. All right. Put your big pants on because you're going to have to do this math. This is the unknown piece that I need. So it's divided, so I'll multiply it to put it over here. Divided 36. I need it by itself, so I'm going to divide by tan 36 to get it by itself. So I have A equals 3 divided by the tangent of 36. Now, if I'm using my graphing calculator, I have to make sure my calculator is in degree mode. So I press mode. I go down to radian degrees. I've been using this calculator in degree mode, so I press it on that, press second quit. 3 divided by the tangent. Tangent, where is that? It's right here. Of 36. That's 4.129. So I know that my apothem is 4.129. My base is 6 because they gave that to me. The area of one triangle is to have the height times the base. So 1/2 the 4.129 times 6. Oh, I put 1/2 the height times the base, but it's the same. 1/2 the base times the height. All of this is multiplied, so it's going to be the same thing. I'll show you through the calculator. 0.5 times 6 times 4.129 is 12.37. So area 1 is 12.387 units squared. The area of the polygon is going to be 5 times that because I got 5 of those triangles. So the area of the polygon is, I just say times 5. Take my answer times 5. 61.935. So the area of the polygon is 61.935 units squared. These are your longest notes of the day. You need to pause, go back over it, and see if you missed something. Now let's do our last one, the hexagon. Hexagon has 6 sides. So my central angle is going to be 360 divided by 6, which is what? 60. Central angle is 60. So what I'm saying is from the center, this is 60 degrees. If that's 60, when I divide it in half, this is 30, and this is 60, and this is 90. I know what my base is. My base is 8 units. It's right there. This side is 4, and this is 4 if I divide 8 into 2. So I have a 30, 60, 90 triangle I'm dealing with. X squared of 3, 2x. That means the short leg. Then we have the short leg times square root of 3, which is our long leg, and 2 times the short leg is our hypotenuse. What do they give us? We got the short legs. The short leg is 4. So the long leg is 4 square root of 3, and the hypotenuse is 2 times 4, which is 8. So what the apothem is, if this is 4 square root of 3, just like we found. So that's going to be 4 square root of 3. The area of one triangle is 1/2 the base, which is 8 times the height, which is 4 square root of 3. So we're going to put that in the calculator. 0.5 times 8 times 4 square root of 3. That's 27.713. And I'm going to multiply that by 6 to get my polygon area. So it's times 6, 166.3. That's the area of my hexagon. All right. This can be daunting, but don't allow it to be. Just go back and review your notes and then reach out to me through Teams in your class period and or email me and I can help you out. All right.